Okay, gang, so for number 11, the domain is x cannot be plus or minus 1. We're doing, you factor this, you can't divide by 0. Now we're doing concavity, so that's second derivative. You have to look for the critical points, which is similar to how you find the critical numbers. This can't equal 0. This also cannot equal 0 because of the plus sign. And this here, we would get plus or minus 1, but that's already a domain restriction. It can't be in both categories, so I can't include it here. So I actually have no critical points. That doesn't mean that you don't put anything on the graph, because on your number line, because on your number line should go any domain restrictions and critical points. So because I don't have any critical points, I still have to put up the restrictions. Now I like to put a big X here, so because later on you don't want to draw any conclusions from that. Not in this problem per se, but if we were asked to find inflection points, these aren't inflection points, they would be vertical asymptotes. All right, so same procedure, you're going to do test points. You plug this test points into the second derivative. So just before I get started, I'm going to note that this is always positive and this is always positive, so I'm not going to waste my time. This on the bottom can be positive or negative. So that's where I'm going to focus. So I got a positive times a positive. If I put in -2, that's going to be a 3. So that's positive. So overall, this is going to be positive. This is concave up. If I plug in 0, this will be negative, because you're going to get -1 cubed, which is still -1. So you got a positive, positive, negative. Overall, that's negative. That's concave down. All right, if I put in a 2 here, you get a positive, positive. 2 again, this would be 4 minus 1 is 3. 3 cubed is positive. So overall, this is positive. Second derivative is positive. That's concave up. All right, now again, this is telling you you're using the second derivative to find out characteristics about the original function. So what the second derivative is telling you about the original function is that it's concave up on the interval from -infinity to -1 and from 1 to infinity, and it's telling you that the original function is concave down from -1 to 1. And that's all they're asking. They just want you to, these first few questions just want you to start to understand and get competent at how do you find concavity of the original function, okay? All right, gang, that's it on this. That's all they're asking for. I hope that helped.